Okay, so today we're going to go over the unit circle. The unit circle is a circle with a radius of 1 unit. So because our radius is 1 for each point on the circle, sine, cosine, and tangent are defined as the following. So sine is going to be y over 1, cosine is x over 1, and tangent is y over x. Also, these can simplify to just y and just x. The coordinates of a point can be written as cosine theta, comma sine theta, where theta is an actual degree. So basically for this, the unit circle helps us to see trig ratios for certain degrees that we commonly use, like 30, 60, 90. It allows us to see them with a simple circle with an easy radius of 1. This will apply to any triangle, no matter the size of the side lengths. So if I instead have a radius of 25, sine of 30 degrees is going to be the same as if my radius is 1. So here's some common values we have: 0, 30, 45, 60, 90, 180, 270, 360. You're going to need to memorize these angles. Also, on this chart, I'm going to go ahead and fill in the radians. We'll cover that later. But 0 is 0 radians, 360 is 2 pi, 30 is pi 6, 45 is pi fourths, 60 is pi thirds, 90 is pi halves, 180 is pi, and 270 is 3 pi halves. So we'll cover that later when we learn radians. I just want to get you this chart right now, so we're just going over that right now. Then, if I look at this circle right here, 0, 360 is this point on the circle crossing the x-axis. My sine value, remember, is y. So because my y value here is 0, it's not going up or down. My sine value is 0. Then, because I know I have a radius of 1, I know that this whole distance from the center of the circle to that dot is 1. So my x value is 1, which makes my cosine value 1. Then to find tangent, I want to do 0 divided by 1, which just gives me 0. And then my coordinate point is cosine, so that was 1, and then sine, which is 0. Okay, so like I was saying, this has a hypotenuse of 1. And I know that it's 30 degrees because it tells me it's 30 degrees right there. So remembering our 30, 60, 90 triangles, what is the length of this line right here going to be? Yeah, it's half of the value of my hypotenuse for 30, 60, 90. And then I'm going to rewrite that as 1/2. Okay, what is the value of this line right here going to be? Look back at your notes for the 30, 60, 90. Square root of 3 times the 1/2, right? Oops. So if I multiply those, it's just going to be the square root of 3 over 2. How would I write that as a coordinate point? Which one of these two numbers is my x value? The square root of 3 over 2. Remember, horizontal distances are your x's. Okay, so then I'm going to do the same thing for my 45. So I know that my radius is 1. For a 45, 90 triangle, what is my leg length? For 45, 45, 90, it's my hypotenuse divided by the square root of 2. But I don't like radicals on the denominator, so I rationalize it by multiplying by the square root of 2 over the square root of 2. Which gives me square root of 2 over regular 2. Okay, and then 45, 45, 90 triangles, the two legs are the same length. So I know that this leg is also square root of 2 over 2. So then what's my coordinate point here? Yep. Okay, so then at 60 degrees, I have this triangle. Which, if you could see, I did in a completely different color. I really hate my projector. So, my radius again is 1. It's a unit circle, so it told me on the front side that the radius of a unit circle is always 1. You forgot what a radius is?
No, I know what a radius is.
Oh.
Put it in, like,
We're doing special degrees, so like 30, 45, 60, 90, like common increments. So, guys, stop talking. The shorter side is right here. This is a 30, 60, 90 triangle. So what's the length of my shorter side? One half. And then the length of my longer side of a 30, 60, 90, we found this one before. It's what? Okay, so my coordinate point here is going to be, which one was my x value? 1/2. And then square root of 3 over 2. Okay, so this one should be a little bit easier. I have this point on the y-axis, so that means my x value is, and I know my radius is 1, so this point is 0, 1. Because it's a unit circle with a radius of 1. So the distance from the center to the edge of the circle is 1. Okay, so on the 120, if I go to draw this triangle, what do you notice about this triangle? Opposite of which one? It's the opposite of 60. So my height should be the same, right? It's just reflecting over. Okay. What about my length on the bottom? Okay. But it's on a coordinate plane, so is it also going to be positive 1/2? Negative 1/2. So then my coordinate point up here is going to be what? Mm-hmm. Mm-hmm. No, these angles are always the same no matter what like, the unit circle helps us remember all of the angle ratios, but like if my side lengths were different, but I had the same angle measures, it would always be the same. So like sine of 30 degrees is going to be the same no matter if my side length is 2 or if it's 1/2. Like, it's always going to be the same. Okay. So then I'm going to do the same thing for my 135 triangle. Which, is it the same as the one I've already drawn? Which one? The 45. So my height is going to be, and my length is going to be, so then my coordinate point is going to be, okay. How do we find the side length? Remember our special right, well, you might not remember. Our special right triangles that we learned on Monday, the 30, 60, 90, and the 45, 45, 90. You should have learned those in geometry. They have the same side length for each of those, and that's how we found it. Okay. So what about the 150? Is this the same? So my height here is going to be, my height is 1/2, and then my length is, yep. So then my coordinate point here is, okay. What about this coordinate point right here on the x-axis? Yep, -1, 0. Okay, so I'm going to continue filling out this circle. So I'm going to go to 210. Okay, I already have my side length right here. I already have that labeled because it's the same as the 150. What's my distance from, guys, distance from the x-axis on 210? Is it still positive 1/2?
No, it's going to be negative.
Yeah, now both are negative.
So it's like a graph.
Yeah, because I'm on the coordinate plane. So honestly, getting the first set of triangles is the hardest. The other, you just remember to change your signs based on what quadrant you're in. Okay, so 225 is the same as the 135 distance. And then what is my height? So the distance from the x-axis. Yep. So then my coordinate point here is, oops, where is it? And I'm going to go do my 240. Which I have my length right here already labeled. And then my distance from the y or x-axis is no, the negative 1/2 is the one they share. Yeah, negative square root of 3/2. So my coordinate point here is Okay, 270, what's my coordinate point? Oh, wait. So, my distance right here, so I'm going across the x-axis negative 1/2, and then I'm going down negative 3/2. So remember, this is x, and this is y. What's 270? Yeah. 0, negative 1. Okay. Then I have 300. So I have this length already labeled. That's 1/2. And then my distance from the x-axis is negative square root of 3 over 2. Okay. So my coordinate point here is okay, so 315 matches up to the 45-degree one. So my leg length there is the same, and my vertical leg length is square root of 2 over 2. So my coordinate point is, oh wait, is this positive or negative? Negative. So my coordinate point is and then I have my last triangle, 330. So I have my distance on the x-axis already measured. What is my vertical distance? No, this one's just negative 1/2 because the square root of 3 over 2 is the x value. So my coordinate point here is what number comes first? No. Yeah, the square root of 3 over 2. The horizontal always goes first. Okay, so these numbers will always be the same. And like I said, if you can generate the first quadrant, you can come up with the other ones based on that. So in this bottom corner, the trig values we went over on the front side. Sine is always y, cosine is always x, tangent is y over x. So in my first quadrant, sine was positive or negative? Cosine was positive, and tangent was positive. Everything's positive in my first quadrant. Cosine is x. Okay. So then sine in my second quadrant was no. Positive. That was my y value. And then cosine in my second quadrant was negative. So tangent is sine divided by cosine. So if I have a positive divided by a negative, it's going to be So my third quadrant, sine is negative. That's my y value. Third quadrant's this one. Cosine is negative divided by a negative is So in my last quadrant, sine is negative, cosine is positive, and then a negative divided by a positive is negative. Okay, so then I want to go back to the front side and finish filling out that chart. So this is just copying the stuff down from the other side. At 30 degrees, what was my value of sine? One half. And then my cosine was? Okay, so tangent is taking this sine and dividing by cosine. Okay. Remember, if I take a fraction and I divide by a fraction, I flip it and multiply by its reciprocal. So notice when I do that, these 2's can cancel out. And I just have 1 over the square root of 3. But do I like?
No, so you multiply it by the square root of 3 and square root of 3.
I'm just going to continue in the next box. That gets me square root of 3 over 3.
So it's just...
Mm-hmm.
Couldn't you just make it?
It's not 3. It's the square. It's 1 over the square root of 3. Okay. So my coordinate point on 30 degrees was... Remember, your coordinate point is cosine sine. Okay, so 45 degrees. What was my sine? Okay, and my cosine? Okay, and my tangent's going to be the square root of 2 over 2 divided by the square root of 2 over 2. Anything divided by itself is 1. So then my coordinate point here is square root of 2 over 2, square root of 2 over 2. This is just so I can organize the information.
Oh.
Okay, 60 degrees. What was my sine? Yeah. And then my cosine? My tangent is okay, so if I rewrite that, it's this. So my 2's will cancel out here, and then I have square root of 3 divided by 1, which this one's a little bit easier than the last one we did. It's just square root of 3. Bless you. Bless you. Okay, what is my coordinate point here? Oops, what? How did I? Where did I get what? Oh, sorry. Yeah, I made a mistake. Okay. 90 degrees, what's my sine? Sine is my y value. 1. And then cosine is, and then tangent is sine divided by cosine, so 1 divided by 0. No. No. I'm dividing by 0. No. You can't do that. Undefined. Yeah. Okay. So then, what's my coordinate point here? Okay, 180. What's my sine? And my cosine? Okay, then I have 0 divided by negative 1. 0. My coordinate point? Negative 1, 0. And then 270, my sine. And my cosine. My tangent is negative 1 divided by 0. And my coordinate point is does anyone still need this side up? I'll let you see that in a bit. This part or higher? Okay. So it's important that you remember the first quadrant of the unit circle. I don't remember if it's the quiz or the test, but one of them you're going to need to know these ratios for it. So like what sine of 30 degrees is or sine of 45, those kind of, yeah.